Hello, everybody. I have a pleasure to invite you for yet another talk during our Java Path in Java conference. This time, Jan Siekierski from Kentra will be talking about the Kafka and Confluent Cloud and altogether about the data products. Jan, the mic is yours, the stage is yours.
Thank you. Hello, everyone. My name is Jan Siekierski, and this talk is about streaming data products. And Kafka and Confluent Cloud are just examples that implement certain ideas that I'll be talking about, because the whole talk is pretty abstract. So I want to give something concrete that will be easier to grasp if certain aspects are new to you. 2 words about me. I've been doing JVM applications for roughly 10 years, Java and Kotlin. About half of the time I was leading development teams, and my area of focus for a while has been data streaming and microservices, hence this talk. To give you a brief idea of what this presentation will look like, this is the agenda. First of all, I would like to set up some context about what do I call streaming data products and what they are called in general. And then I will come up with certain proposition of how can you establish standardized data streaming in your organization. And after this, I want to bring in some recent technological developments in this area. Why do I think that this topic will be relevant? More relevant than it was before. And after all of this, I'll try to summarize this with some generic recommendations that can be applied depending on where you or your organization is right now in this area. So first of all, the context. A data product is a term that's been, I think, established primarily in the analytical space. And the definition, I've seen many definitions, but the one I like that's rather minimalistic is that it's a reliable, reusable data asset that's created with customer value in mind. And customer value is the primary value factor here, but reliability is very important as well. And what this means to me, and what I think the distinction is between a product and not a data product, is that once we publish faulty data, we fix it, and our customers, our users can rely on the fact that faulty data will be fixed. Not only we remove the bug, but also we fix the issues caused by it. And a bit wider definition of what a good data product is, so the fully wide solution, is that it will have a clearly defined ownership, and the owner will be responsible for feature prioritization and client support. All of this is oriented around customer value. There is this commitment to fix faulty data. And the ease of use is facilitated through self-service and interoperability. Interoperability often means multiple output ports. So even though our product is coherent, it might be available. The data might be available to your customers in a few different ways. And also, a good data product will be documented and discoverable. And this is often facilitated by a special category of systems that are called data catalogs. The important point here is that this is primarily an organizational change that is facilitated by technology and not some major technological innovation. This is just the way that you structure and publish data. And streaming data products, this is application of data streaming to this concept. Streaming data products will be a subset of data products that are built using streaming technologies, or in other case, data streams that you promote to the data product status, because this comes also with certain commitments that from now on your customers will expect for you to fulfill. And to give you a rough idea of how such product could look like in a, let's say, a standard application, your application will publish data to a Kafka stream, and then either you can make this stream accessible directly to your customers, and then you call this stream your domain boundary. Or maybe you would like to enable a few output ports, and then stream would be one of those, but maybe you would like to publish a daily snapshot to an S3 bucket or something like this. And the main question that I would like to explore today is how to share data efficiently in an enterprise. And data streams seems to be a good and adopted solution for this purpose, because this is just very scalable and fitting for many problems that are present. And the why behind standardization is, first of all, the network effect. The larger the organization, the more possible connections between different applications, different teams you can see. And also, each of these applications can be built in a different technology, so some standardization just brings efficiency here. And sharing data, it's a problem that occurs everywhere. It's pretty standard, so standardized solutions and approaches are implemented for this purpose. Another big driver of this is regulatory compliance. And regulatory compliance is not optional. So if you are obligated to protect customers' PII data or support the possibility of a financial audit through full history access, this is very often solved in many different teams independently. So the data streaming world came up with some standard approaches to this problem. And if you do it right, you get the efficiency, because instead of solving the same problem 10 times, you move this solution to the platform side, and it's supported in a centralized way. You get the reliability, because suddenly you can give up on certain defensive aspects of designing stuff if you have, for example, data quality built into the data contract that of the product that you're using. And also, clarity is a major benefit. It helps with onboarding. If you have an extracted interface of your domain, it's usually pretty much quicker to understand what's going on inside. And also, when you approach the problem of designing big features that touch multiple domains, very often people doing this will not be super familiar with the details of each and every one of them. So it's very helpful to have a clear standard way of mapping and visualizing things, and standards really help with visualization. And also, as everything, this comes with a cost, and one of the costs of standardization is friction. You might get some resistance if you don't establish the right standards. If you get too many questions, then this will harm the adoption process. And also, some solution designs will not be possible if you expect your teams to conform to certain standards. And yeah, it needs many conversations before standards are adopted. And also, this is a shift left, which means that there will be a heavier burden on the data producers. And it's valuable to make sure that the data producers that adopt this approach, that they are on board with all of this. And before I talk about how such standardization can look like, I want to highlight a few problems, a few questions that will happen during this process. So first of all, there is significant difference in the load profile of operational and analytical plane. Operations, your applications that we are building, we are using, usually require low latency, and they process data on single transaction, single row level. Whereas analytics, usually they have fewer users, unless you do user-facing analytics, which is a separate problem. But usually the analytical platform has fewer users, process data in big batches, and you access historical data, not just a single object, but large batches of data that often aggregates a long period of time. And because of this, the two popular storage orientation formats are popular in those planes. In operations, row orientation is much more popular. An example of this is Avro. In the analytical plane, column orientation is much more popular. Example of this is Parquet. And the reason for this is with columnar orientation, you get much higher compression efficiency with large data set, especially with wide data sets that have 20 or 50 columns. And also query engine support for specific kind of queries that are executed in analytics. For example, if you have 50 columns, but you're only interested in 3, it's much easier to just read these 3 columns, and you get much better performance. It's a bit out of scope for this conversation, but I want to highlight two interesting technologies that are under development or just recent developments, TableFlow and Flask, because the data streaming world is trying to bridge this gap. I think this world is aware of the fact that streams are primarily built for operations today. It hasn't been bridged yet. I don't think so, but a lot of effort and a lot of money is being spent to fill this gap, and I'm really curious how it will look like in 1 year from now. The communication mode for streaming data products, here we have a clear winner. Publish, subscribe is just very natural for this use case. Point-to-point might happen from time to time. You might have customers that have significant influence over how you build things, and that might just require you to conform to what they expect. But publish, subscribe is just clearly superior here. And when you try to talk about standardization, schema management is not optional, and you will need to establish certain conventions. It's really helpful to talk about the serialization format and how you manage backwards compatibility or forwards compatibility before you start building production systems. And I want to highlight something specific to Kafka and schema registry topic record name strategy. This is the approach that allows you to store multiple different record types or message types in a single topic. This means that different events can land on the same partition, which means that they will be processed in sequence by your consumer. And this takes this responsibility from solving this on the consumer side. It really makes your life much easier. But it is less supported because it's a bit complicated to handle on the tooling side. So given this possible choices you can make, the last one and the big one is decomposing the whole organization, logically decomposing this, and domain-driven design is a great and really popular in the Java world approach. It's not the only choice. Like data modeling, enterprise data modeling, it's a discipline in of itself. But I will be using the DDD approach here more as an example than as a proposition of solution. So first of all, you would decompose the whole thing into domains, and these domains would be independent and they would be interfacing with each other, but each domain should be a whole independent thing. And within the domain, you will identify aggregates. A practical example of this would be an e-commerce store that has probably a cart domain. I'm not very familiar with e-commerce software, but I imagine that you would have a cart that would be an aggregate, and on this you would be adding products, removing products, and moving cart to checkout, and so on. You will pretty much always have, and this is a solution proposition already, but you will have two different types of streams. First one is what you probably understand as a stream, so unbounded stream, where you would store domain events that are happening on your aggregates. The other one is compacted stream, which is more like a table. This was introduced in Kafka streams because every insert into your stream, or every time you publish something to your stream, this means that the previous record under your key, because every message has a key and a value, the previous message under this key is no longer important. And this is a good fit for something like a product catalog. If you want to use your product catalog to have access to like product names, prices, and so on, this is a really good fit for a compacted stream, whereas unbounded stream, it's really good for just business events. So having said all of this, standardized approach to publishing data streams, and that are a component of your data products. I've built this in more than one organization. So this is a separate repository that defines your domain boundaries. And we are building this for operational plane only. And this domain boundaries repository will have your topics and your schemas defined as the interface of your domain. And I'm not talking about columnar data formats or REST APIs here. They might be also present here, but I'm talking about data streams exclusively. yeah, and unbounded streams will be containing domain events, and compacted streams will be containing snapshot of the state that you might want to publish to the rest of the organization. And it would also talk about this shared conventions about stuff like schema management, API deprecation, and so on. Yeah, so all of this was possible a long time ago. So what changed, and why do I think that this is worth talking about today? Well, yeah, and a lot of organizations were doing this years ago, but I wanted to bring into your attention certain important developments in the data streaming world. These are these three big features, and I'll go through them one by one. I'll start with stateful stream processing. And stateful stream processing is an area that's growing. One of the symptoms of the development is that fact that serverless sync is available on Confluent Cloud, I think since last year. But while great news for users of Confluent Cloud, I see this as more of a symptom that stream processing world is growing. The ecosystem is maturing. The good previous solutions are getting more mature, more production ready, and easy to use. And also a lot of new solutions are coming up on the stage and trying to get some value of this world. And stream processing, the most important functions that you can achieve by using it is, first of all, joins and transformations. And for our cart example and our product catalog example, you could consume this product catalog and store something in your cache, like in a DynamoDB table, stuff like this. But you can also just make a join in your stream processing engine, and then you just have everything you need in place. So it really makes your life easier in certain cases. And similar with aggregations. I remember that event sourcing was considered a very expensive approach that's valid for certain cases, but definitely not a standard, not something you do. It will just become much easier because like aggregating your sales from the previous hour or so, this is much simpler with the capability to do stateful stream processing. Real-time data pipelines also is an important aspect because your data loses value over time. The data is most valuable whenever it happens. And there are some cases where it doesn't lose that much value, but certain cases where your urgency and your ability to react quickly is critical, like fraud detection, like anomaly detection, but also customer retention. If you have an e-commerce store and your customer is using your application and building a cart, but then stops responding for an hour or two, you might want to send them a message that, yeah, we have this discount for you. Maybe you come back and take a look once again. And this is what's being done in many organizations. And observability in general, if you have a platform where you do a lot of operations, these platforms are packed with features that you wouldn't do if you didn't have this platform. If you were to code your Kafka consumers personally, explicitly, some of this you would build, but some of this you wouldn't because it wouldn't be feasible. And that's another point that I'm trying to make, that stream processing doesn't enable many groundbreaking new cases. It just makes all of this much easier, much cheaper, and because of this, you will just get more if you start using tools from this class. And there are many. Flink is just one example. Another important development that I wanted to mention is the rise of data catalogs. They're also called metadata platforms. And again, this is development coming from the data world. This is a new class of systems that implement or facilitate discoverability, documentation, governance, and data lineage. I've given a few examples. In Confluent's case, this is Stream Catalog, also supported by Stream Lineage. But Event Catalog, Unity Catalog was this open sourced, I think, early this year by Databricks. So there are many systems in this class, and this growing of this ecosystem is facilitated by demand because it makes your life much easier if you can just visualize. If you define your domain boundaries, you can just see all of this and many different domains with a standardized tool. You can see a data catalog where you know that you need something from product, but what's available? Let's take a look. Yeah, this is supported by this discoverability feature, and being able to explore this as a user. And the last feature, I think the most important one, is connected to the fact that historically operating a Kafka cluster was considered by many people who I've talked with and many sources I've seen as both expensive and complex. That this is a direct result of how Kafka is built, and that Kafka was designed and built as a stateful broker, where the data that's present in your partitions is persisted on the hard drives of your brokers. So this comes with, this was a great solution at the time, but comes with certain problems. And one of these problems is that you get, because you store 3 copies of the data, you pay for the network traffic immediately. If you want to have a highly available setup in 3 different availability zones, you incur significant networking fees. But more importantly, if you try scaling up or down, you need to, and you have tens of terabytes, hundreds of terabytes of data there, you need to rebalance the partitions so that your data is distributed rather evenly. And this incurs significant networking costs. So the result of this is that just this scaling up or down is not being done. So you don't do it, even though your application is not working. You cannot just scale down for the night and bring this back up in the morning because it's very expensive. And this is also tied to coupling your storage with your compute. So a lot of compute gets wasted. And the solution to this is tied storage, which, to put it simply, means that your data is no longer on the hard drive of the instance, but instead it's quickly moved to an object storage like Amazon S3. And Confluent Cloud and Red Panda have had this feature available for a while, and it was available in Common Kafka, but it was in early access or pre-production. I don't know what the term is. But since Kafka 3.9, which was released early November, tiled storage is declared production ready. And I think that this really is a game changer that's supporting the concept of streaming data products in a very significant way. Because first of all, you no longer have this terabytes of data. You just keep your disk as a small buffer on your brokers. But most importantly, this distinction is already available in Red Panda. And as I was talking about unbounded stream and compacted stream, both of those will come in 2 flavors. One is the regular low latency stream, where you store this data for a while. And in Confluent's case, this is 15 to 30 minutes. You store this on your instance storage. And then after certain time, you move this to S3, and then you can, instead of having 14 days of history, you can have 6 months or 5 years of history if you need. But the second flavor is fully cloud, like topics that you store on S3 only. You don't introduce this buffer of a disk, because this buffer introduces an additional cost. So your broker becomes stateless, and Confluent is introducing a feature that's in early access today called freight clusters. They claim 90% reduction in the costs of operating your Kafka cluster. And because you have this trade-off between cost and latency, you need someone, and this someone is data product owner, that's accountable for the costs, because they will publish different types of topics. So these are the 2 existing solutions. First of all, the tiled storage, where you use a disk as a buffer backed by S3. I've given a summary. This presentation will be available for download, hopefully. I've uploaded it to the software that's supporting this. But these 2 architectures, the left one and the middle one, they are present already. So you can use your disk as buffer backed by S3, and then you have roughly 80 milliseconds of P99 latency, because you need to move data between your availability zones. And you do incur roughly 5 cents per gigabyte, a bit more, when you write data and replicate this to different availability zones. And then you pay for S3 storage, which is 2.3 cents per gigabyte per month. which roughly means that each gigabyte of data you write costs roughly as much as storing this for another 2 months. And another architecture is S3 only. This is called Cloud Topics in Redpanda. The P99 latency of warp stream, which is a technology acquired by Confluent, which I like a lot, they claim they have P99 of 400 milliseconds of write latency. You still need to consume it, but write latency 400. And as this is stateless, you only incur the cost for storing the data. And another architecture that I think is a sign that something very interesting could be happening soon, because if they do it, then somebody else will do it soon, and then others will come up with even better ideas. It's an architecture that tries to tune this even more, because instead of writing to S3, you write to 3 instances of single AZ S3 service. So 3 different single zone S3 buckets. Once you write there, you send a confirmation to your producer. Yeah, I have it. It takes roughly 150 milliseconds for 99% of the cases. And then the agent, the warp stream agent, moves the data to S3. So you do incur the networking costs. So you lose the low cost benefit. You get roughly twice as much latency as you do with the traditional approach, but you have a fully stateless agent, which is a significant benefit. And this is only one of the innovations in the space. I'm really looking forward to seeing what else will be there. Yeah, so this is the three layouts that are present right now. I'm really curious how this whole world will develop. And this was vast majority of the content, but I would like to summarize this with something that you could use for in your organization, whatever your role is and wherever your organization is. So I've prepared lists of features that are prioritized by my generic calculation of cost and value. So take this with a grain of salt. And I've divided this into 2 sections. One is the data streaming platform side, and the other one is the domains, because defining these domain boundaries, this is a repeatable process, but it's great if it's standardized between different domains. So on the data streaming platform side, the data cluster provisioning and access control, preferably service, it's the baseline. But then once you have it, tired storage is extremely valuable. Also could be pretty expensive if you are doing this yourself and not using a cloud provider. Data catalog is very important. It's tailor-built for data products. So if you do a standardized setup of your domains, you can usually rather easily plug this into a data catalog, as long as it is supported by the platform. And after this, stream processing, very valuable, but I think it's pretty expensive to introduce if you need to introduce this yourself. And cost allocation and data contract is great if you're a data owner and is able to track costs of the usage of your platform. And it's great for the platform team to know that they are supporting 8 different domains, but one of those is using 90% of the traffic and incurring 90% of the cost. Then you can have a conversation about, can this be optimized? So cost allocation is valuable, but not top priority, not something that drop everything and start building this right away. And data contracts, data products, data contracts is a concept connected to data products that were, apart from the schemas, you also commit to certain SLAs or certain aspects, non-content aspects of your product. Basically, what you provide to your customers, and there are many propositions on how to standardize this. Nothing is established as a global standard yet, so just a few pretender technologies that aspire to be the global standard. And yeah, it probably depends on your tooling whether this is feasible for you. And on the domain side, the baseline, it's not that complicated to build. It's a repository where you store your schemas and your topics. And this repository is integrated with your schema registry. So every pull request that's merged is deployed to your schema registry. So you know that it's there. You don't have to guess or don't have to check. And also it's integrated with your services. So in case of Java applications, your schemas get packed in a jar file, published to Artifactory, and then a service that wants to either produce or consume the contract just upgrades the contract version. So this is the baseline. I think that with this, you can call it a data product already, as long as you fix corrupt data. And on top of this, then the next part is the conversations about conventions. They can take a while, and you need an alignment of many stakeholders. So this might not be something that one person can do, and a bit less lower in priority, because there is a dependency here on the data platform team, and platform capabilities is the integration with the data catalog and implementing data contracts. Yeah, so this was more or less all. If you would like to give feedback about this, the QR code to scan this is here, but I think also there is a button in the application. And I would like to thank you very much for watching. My name is Jan Siekierski, and if you'd like to follow up on this, ask some questions. I don't think we'll have much time for Q&A, but you can do this either on LinkedIn, or I will be present on the venue tomorrow in person. Yeah, so thank you very much, and back to the studio, I guess. Artur?
Thank you, Jan. I was looking for a different Tom. Thank you, Jan. Thank you for the great presentation. We unfortunately do not have time for questions. However, we have one short one. Okay, no, there's no questions for our presentation. It was great. It was nice to see. It was nice to see your talk. I was watching it myself. That's why I have a short delay. And it. Well, I hope you will have opportunity to meet with each other next year on the next Java conference. I assume that everyone will have any questions that would like to ask in private. He is able to contact with you on some kind of social media. Yeah, you are fine with that. Wonderful. So thank you very much. Thank you for the great talk. And like I said, see you next year. And enjoy your second day of the conference, because I heard you are going to join the Warsaw on-site part as well.
Yeah.
So probably somebody will have question about the Kafka, about the thing. He is able to grab Jan during the path and ask some questions. Thank you very much.
Thanks.